Hi, it's Landon, and this is BioMechanico, and I'm going to show you a way to demonstrate a population bottleneck and the effects, or at least some of the effects, in one class period. So this is a shorter version of some of the other videos I've shown. So your student will go into their barn. You will in advance have bred a population of animals, and say you choose about 30. I think 30 is a good population where it's big enough, where you have some diversity and enough animals, but also small enough that the students can kind of see the whole thing and kind of get a feel for the whole population. Obviously, this is not representative of an actual population, or at least it's not the size of an actual population. It is supposed to be representative. So you'll just click on that, and it will say where do you want to exhibit it. So you'll select all 30 of your animals at once, and you'll say I want to exhibit this with the Wild Society, and bam. So you'll share all 30 of your animals, or whatever number, and so then they will go into their society barn, and I own all of the animals, so it doesn't show them here again, but they can select all at once just by clicking select all and clone, and that will move them into their private barn. Once they have the animals in their private barn, they can do the exercise. So what I suggest with a bottleneck is, and in this case I have 15 animals, I believe. You get a population and you assign students randomly 2 animals, a male and a female, and you say, okay, all of the other animals in the population died except for these 2, and each student or each group gets a different randomly selected couple. The students can then make a 10 or 15 or 20 animal cross, or 2 10s or 3 10s, or whatever you want to do. It'll take about a half an hour for that to load, for all those animals to load. And when they do the crossing, and I've showed crossing before, but when they do the crossing, it would be easiest if you name the population Generation 2 or Post Bottleneck or whatever. So I'm going to show you. I have them tagged, but I had the tag hidden, so if I click on that, here are my 2 randomly selected animals. Let's see. And I can just search here and it will show me my 2. So I can select those 2, and then I can show here are the resulting animals. You can turn on the extra genes, that's these genes on the right side, and look at diversity in those. I don't have a lot of diversity in the, well, I've lost any diversity. Let's go back and see. Oh man, I forgot what they're called. Are you screaming at the screen right now? Pizza, pizza. So I look at pizza, and do I have any diversity in these genes? These are ABC genes. If you select extra genes down at the bottom, I won't explain it now, but if you select these genes, you'll see a little bit more diversity. And since this video can be as long as I want it to be, I'm going to do it now. Alright, so you see a little bit of diversity there. Maybe you don't. Yeah, you do. Alright, and of course there's the diversity there, and our survivors are heterozygous. So you didn't lose any in the P gene. So you didn't lose anything. Had some of your students selected 2 that were homozygous, you would have lost one of the alleles. So that's something to look out for. And if you add those extra genes like I showed you, just by clicking here, you can look at those. So then we look at our population. With this population, if you use this population, skull shape is a little bit diverse, length of the tooth, you can look at tail length, things like that. And you can also add metrics to measure. I've got fitness here. I just have an equation for rating a type of fitness based on bone lengths and things like that. But you could do number of vertebrae, you could do whatever on this, and I can show that in another video. But that's so you have a parent population. Each student gets their own randomly selected couple, male and a female, and then you breed up the population to 20 or 30 or equal to the original population, and then you compare the 2 populations. And using the gallery, you search there, and then you use the gallery, and you can kind of, this is an easier way to look at some visual differences. This is a pretty uniform population, and for really uniform populations, you really need to get out some metrics and measure stuff. But there are some differences in skulls. But this video is getting long, and I just wanted to show that. So after you do that exercise, you can talk to the students about how those 2 animals that they were assigned affected their population, and discuss how that applies to a population bottleneck and the result.